Hello. So for this problem, you had a question on, I think, C and D, but the mean and the standard deviation, when it's one item, that's given, and it was given as 139,000 and 40,000. Now, when you're having a distribution, notice this one has the mean, X with the line over it. The mean itself is the same, the 139,000, but the standard deviation, you take the 40,000 and you divide by the square root of the sample size, which was 41. Yeah, right here it has 41. And you'll get the 6,246. Now for the single randomly selected graduate, it's just one graduate, then that's part A. We're using this mean and standard deviation. And to find the percent between two values, we go to distribution, so second distribution, and we go to the CDF one. Now you put the lower value, because if you put the lower value on the higher value, it will find the percent between. So our low value right here is 134,030, comma, and then you put the higher value, 139,453, comma, then your mean, which is here, because it's a single, it's these two here. So you put your mean and your standard deviation and hit enter, and it gets you 0.0539. Now on this one, it's the same values, except it's a sample of 41 graduates. When it's a sample, then you're using the mean distribution, part B. So we use these two values for our mean and standard deviation. Now what you could do is go second and enter, and it brings up all our values. And then we just need to go and change the 40,000. So we have our lower value, our higher value, our mean, and then this standard deviation is right here, 6246 point, and hit enter, and we have this one. For part D, is the assumption of normal necessary? No, the assumption is not necessary because our sample size was 41. As long as it's greater than 30, and it was 41.